And oh, there we go. And of course, pay my respects to the elders of the country that I'm sitting on today, which is the Gunai-Kurnai people. I invite you to pay respects in the chat function by typing whose country you sit on today. Of course, back in the day, weeds were not an issue, but unfortunately, they are now part of the landscape, which is why we're here today. So let's get on with it. I will throw to Luke, who will have a quick chat about who's responsible for weeds, why and where.
Thank you, Jeff. Good morning, all. My name is Luke. Today, myself and Katie will be presenting on who's responsible for weeds, where and why. The topics we will cover today include noxious weed classification and responsibility, establish invasive plant management projects, and Katie will present on the Partnerships Against Pest program. So just hide that. So declared noxious weeds in Victoria fall within 4 categories. Shown here are 3 of the most important kinds. Firstly, we have state prohibited weeds. These are weeds that are either not in Victoria or exist in such low numbers that they are feasible to eradicate. Treatment of state prohibited weeds is a statutory responsibility, meaning state government must treat these infestations by law. We have hundreds of cases in the southeast of Victoria, which get visited multiple times a year to ensure eradication is successful. The next classification down are regionally prohibited weeds. These are weeds that are not deemed eradicable from the state as a whole, but are eradicable from some catchment management areas. Last, we have regionally controlled weeds. These are weeds which are most likely to be well known in your respective communities. Regionally controlled weeds are generally well established across a catchment or perhaps the state. Blackberry, gorse, thistles, and ragwort are familiar regionally controlled weeds in the West Gippsland catchment. The highest priority for biosecurity officers in relation to weed management is to work with eradicable state prohibited weed infestations. A large amount of our effort is on state prohibited weeds is taken up by online trade interceptions. Regionally prohibited weeds, which are feasible to eradicate over small areas, are the next major weed priority. The responsibility for them rests with the land manager, where the infestations are found. The expected control standard for a landowner with regionally prohibited weed infestations is to take reasonable steps to eradicate the weed from their land. For regionally controlled weeds, the same applies, but instead of eradicate the weed from the land, the landowner has a general duty to take reasonable steps to prevent the growth and spread of weeds within this classification. To put these classifications into context, here we have the invasion curve. As you can see, there's 4 stages of invasion. These stages can be applied to the classifications of weeds and the types of work Agriculture Victoria undertakes. State prohibited weeds fall within the prevention eradication stages. These weeds are either absent in Victoria or have limited infestations. They have the potential to greatly impact the agricultural industry and environment if they become established. These two stages have the greatest return on investment. As you can see, there's a key at the bottom of this slide. Regionally prohibited weeds tend to fall within the eradication stage, only within the catchment, not statewide, or containment stage. Whilst populations are present, they are not yet widespread across the catchment. Regionally controlled weeds fall within the containment or asset-based protection stages. These weeds are rarely possible for eradication and require ongoing control efforts. This slide is in reference to what may occur at the end of a community-led program or a project referred to Agriculture Victoria by the CPMGs. Compliance projects are typically designed to target a collection of properties within a defined area and are usually carried out to eradicate regionally prohibited weed infestations, contain the spread of a regionally controlled weed, or to provide support to communities where management of established invasive weeds is being undertaken collectively. Typically, in these cases, a thorough inspection of the property is conducted. If the biosecurity officer is not convinced that the owner is taking reasonable steps to manage the weed species, a direction notice may be issued, allowing time for the landowner to take reasonable action. Failing to undertake the prescribed actions outlined in a direction notice may result in an infringement. Referrals from community groups in the CPMG for enforcement such as this will usually conclude with one of three recommendations: enforcement not required, enforcement not justified, or enforcement recommended. Here we have a visual example of the first of the three recommendations. Supposing engagement activities have been run on this collection of random properties, infestations of the weed are practically non-existent, and obviously there's no reason for further government investment into enforcement. Therefore, enforcement is not required. If engagement activities show that the weed is widespread and located across majority of the properties with little coordinated effort to manage the weed, compliance is not justified in such a case. The reason is substantial costs associated with compliance on so many properties and the apparent lack of partnerships between the landowners. Some of the hardest conversations we have are with property owners who are doing the right thing, but are located within this type of environment. Finally, we have the third case, where majority of the landowners and the majority of land is well maintained. However, there are a small number of properties not meeting this landscape-wide standard. This is the case where compliance is justified and may be recommended. I will now pass it over to Katie to present against Partnerships Against Pest grant program.
Thanks, Luke. Hi, everyone. My name's Katie. I'm currently acting as the Engagement Officer for Established Invasives for the Southeast region, and I'm going to talk briefly about our Partnerships Against Pest grant program. Next slide. Thanks, Luke. So the Partnerships Against Pest grants, which I'll refer to as the PAP grants, is a program aimed at expanding collaborative partnerships in the long-term management of established weeds and pest animals in Victoria. There are multiple funding streams for the PAP program, but I'm going to talk specifically about Stream 2, which is available for community-based organisations operating at a local or a regional level. It aims to ensure that the people who are most affected by the problem of weeds and pest animals are central in that process of defining the problem and gives them the opportunity to create new strategies and community-based projects. So the program is currently in round 4 of delivery, and the final year of the grants will be available in 2026. Eligible groups can apply for funding between $10,000 to up to $50,000 each year to deliver activities that align with the program objectives, which I will touch on shortly. So we're looking for projects that target one or more species that are declared under the CALP Act. So for example, for pest animals, this includes rabbits, foxes, and feral pigs, but this does not include deer, as deer are not declared under the CALP Act. The PAP program aligns directly with Strategic Goal 4 in Victoria's biosecurity strategy, which is all about reducing the impacts of established weeds and pests through local action. And it helps AgVic achieve priority action number 13 from the strategy, which is all about enabling industry and community-led action to reduce the impact of established weeds and pests. Next slide, thanks. So in total, the PAP program has delivered nearly $1.5 million in funding to community groups to deliver projects that align with these 5 objectives, which include capacity building, capability building, raising awareness, strategic planning, and partnerships and collaboration. These can be delivered in a number of ways. So as we can see here on the pie chart, this gives an overall view of what the funding has been going towards. And we can link each of these activities back to the program objectives. So for example, for building capacity, we're looking for activities on best practice management knowledge, such as training events, presentations, field days, workshops, and webinars like this one today. Next slide, thank you. So since 2023, the PAP program has funded 43 projects run by 37 different groups across Victoria, which you can see the distribution here on this map. Some examples of the projects that have been funded. We have Wildlife Unlimited in Far East Gippsland. They've been training the community to use technology to target pests by using the app Feral Scan, and they've created a group within the app for the community to record fox activity. Another project that was delivered by Latrobe Catchment Landcare Network, where they created their weed and pest strategy 2025 to 2030, which is a strategy that will continue to go on beyond the lifetime of their project. Round 4 applications closed on the 4th of July this year, and the successful applicants will be announced in October this year. Next slide, thank you. So to finish it off, we have some feedback here from groups that were funded under round 2 of the grants program. And as you can see, it does give a great overview of the impact that these projects are having in the community. And this evaluation and feedback will hopefully be used to fund this program further into the future beyond the current funding rounds. That's all from me, so I'll hand back over to Luke.
Thank you, Katie. This is the opportunity for anyone to ask questions if we have time, Job. I'll take resounding silence as no questions. So if you have any, please pop them in the chat. We're more than happy to answer them.
Sorry, Luke, I was just looking for my sound button.
Oh, no, that's all right,
Have
Rob.
time for a couple questions.
Yeah,
Thanks.
just my
Can
query
you-
is the concerning the
Just
map
gonna
that you
be
had where
out
it
of
was covered in the
screen.
noxious weeds, but it was not worth doing anything about it. Isn't that walking away from the responsibility of landowners and whatever to tackle these things? I mean, with the map you had with just one property clean and that everyone else not behaving themselves, surely we just don't say, oh, well, that's okay, we'll forget about the whole lot.
So that's an area where we would not consider enforcement immediately. It's an area that could be identified where more community-led action is required. So that's sort of the area Agriculture Victoria is moving towards, is enabling all of those landowners to start communicating. And once everyone's on the same page and working together, then there's the potential to come in off the back of that and undertake compliance as a final step. But before we can do that, we need to see that everyone is working together to get rid of the weed, because we don't have infinite money or resources to address all of those areas, because there are a lot of them. We can only really be working in the areas where people are actively working together.
Okay, but it seems to let all those people off the hook. Yeah, so you can encourage them to talk to each other, but if they don't want to, the weeds continue to go wild and spread all over the catchment progressively.
Yeah, so there is another avenue which we do have quite a bit of success with, which is our complaint line. So once we receive a complaint, quite often from that individual landowner, they'll report multiple people. We then follow up by communicating with the surrounding landowners and sort of putting it into perspective. Quite often people don't really understand the impact. Try to identify a few drivers for each of the landowners. Everyone has different drivers and barriers, and try to help them see why it's important to get rid of said weed. And yeah, we usually have pretty good results from that. But some areas, say the core of the serrated tussock infestation in Sunbury or Geelong, they're very difficult areas to work with.
Gotcha. All right, thank you.
Thanks, Rob, for that question, and thanks, Luke, for fielding it. In the interests of time, we will keep moving, but if you do have more questions for Luke or Katie, please pop them in the chat function and we'll get them to do the best to answer those online, and if not, afterwards. I'd now like to pass on to Ray Kwong from AgVic, who will be sharing with you some past research and projects and also current research and projects about biocontrols.
Great. Thanks, Joe. Can you see my PowerPoint presentation?
It's just taking a moment to load, but dare say it'll be on screen very shortly.
Yes. Okay. Well, hopefully, while it's loading, welcome everyone. Thank you for coming along and listening to my presentation. I am talking to you today from Yakandanda, which is the lands of the Dudgeroa people. Yakandanda actually means, in the Aboriginal meaning, a rock on top of another rock at the junction of two creeks. So if you've ever been to Yakandanda, look out for the rocks.
Zoom is doing some funny things. I just got booted out, which is why I disappeared momentarily. So I'm glad to see you still all online.
We did test all of this morning, mind you, for those people who... It's always the way, isn't it?
In the meantime, Joe, could we maybe throw to Robin and
Yeah,
while we get this
right,
sorted?
right back. Robin, are you happy to jump online and have a chat about weed control success and what you need to be considering, and field any questions for Robin? Robin works as a consultant. He's been dealing with blackberry and a number of other weeds for a long time now. So he's also part of the Victorian Blackberry Task Force.
Okay, I don't have a PowerPoint presentation, so I think things are going to work okay. All right, so there was some questions put up that this webinar would like me to discuss, and that was what are the components of a successful control program? Well, I reckon that's a really good question, and it's such an important one, and I'm proud to be able to contribute to that, because that question determines what sort of actions we might undertake to implement a control program. And it's a question that's best asked proactively rather than retrospectively, because it determines basically what we're trying to achieve. And that kind of goes back to what Ben was talking about, the 4 types of control programs that you can have. That can, I'll just reiterate those. It's the prevention approach, the eradication approach, containment and suppression. So I'm just going to, from a practitioner's point of view, kind of talk about some of those things. But it's never simple. That's kind of in the basic sense, but in the real world, generally what we're dealing with is a mixture of all of those things together. But for this discussion, it's probably best just to break them down into the 4 components. So we can start from a theoretical concept, and that will help us kind of understand what's going on. So I just wanted to touch on prevention. Now, normally that's something that's applied at a state or national level, and we're all pretty aware of those sorts of things, but there's no reason that a preventative approach can't be applied to a much smaller landscape unit. It can be applied to a national park, a farm, or a landcare group, and that's about stopping something that you don't want to enter that landscape unit. So it's a very proactive approach, and most definitely it's one of the most cost-effective methods that we can undertake, but sadly it's one of the least practiced. Essentially, the reason being is that a lot of people tend to focus on their own properties or their own jurisdictions and not look further afield. For example, if you've got a national park that's free of Spanish heath, but there's a big infestation 5 kilometres down the road, it generally never gets treated. But if we're to take a preventative approach, then that infestation might be treated, so it prevents that infestation from moving into a national park, where it would cause a lot of damage, and once it's in, it probably never be able to be removed. So I would definitely like to see that approach understood better and most definitely applied to smaller landscape units, because the benefits are massive. So the measure of success with something like that would be that the target in question never enters your unit of land, whether that be a farm or national park or landcare group. And that's a pretty easy metric to get a handle on. Moving up the invasion curve to the next level, eradication. That's a lovely thing to achieve, and a lot's been written about that, and many of us have tried eradication for various weeds at various scales, and in principle it's a fantastic objective, but it's really hard to achieve, essentially. And before undertaking an eradication program, you need to be very careful on what sort of targets are selected, because it might end up being much more difficult than you think. So the main reason for this is that most weeds, perhaps probably nearly all of them, are very tenacious. They've got aspects in their biology that won't allow them to be eradicated easily, and they'll hang on. So when undertaking an eradication program, some of the components that need to be taken into consideration are the extent of the infestation, the biology of the plant itself, and how long it's been there. So with a weed, for example, an annual weed, let's say thistles is a good example. Well, it's a biennial weed. We do have some annual thistles. If it's, a large infestation, it's been there a long time, and because it's an annual, eradication is going to be a really difficult thing. And eradication is not just taking the aerial parts of the plant out, what you can see on the ground, it's removing the soil seed bank as well. And that is one of the most difficult things to achieve at a practical level. Managing a soil seed bank with a weed infestation, if you can do that, you'll get on top of it. So with eradication, often the very successful targets are plants that don't produce seeds. These are plants that produce, reproduce by vegetative means. Some of our aquatic weeds are like that. And we do have other, a small group of terrestrial weeds that don't produce seeds. They're reasonable targets for eradication. And the duration of an eradication program, because it can be difficult, we're looking at long periods of time. At its fastest, it might be 5 years, depending on the species, but realistically, in the case of a legume, for example, or bone seed, which have got very hard seeds, they sit in the soil for a long time, we're talking feasibly probably decades. So, that's, if you're embarking on a program like that, that comes with it a pretty hefty cost. So that's why I'm saying that, eradication needs to be carefully considered, needs to be generally when a weed is only newly arrived and the infestation is not very big, but it can be applied at a small landscape scale. So the measure of success with something like that, whether it be a farm or national park or whatever it might be, is that the species is completely removed. And when I say complete, it's not just the aerial parts, it's the reproductive structures that might be sitting in the ground as well. And that measure needs to be undertaken, not in the first year after control, but, several years at least, up to 5, more practically.
Robin, can I just jump in there? Just keeping an eye on the chat function for you. I've got a question from one of our participants who's battling English ivy, which is right across a school area and bush areas. And the question is, what do we do with something that's that large scale?
Yeah, okay. Well, that again, it embraces that concept that I mentioned before, where in some cases you might look at eradication of, going back even one step, you can prevent it from arriving in the first place. You can eradicate. English ivy is not a hard plant to kill if you know what to do. And so eradication can be feasible at a small scale. But generally what we're seeing in Victoria is English ivy, very common in the landscape. And the question will be, well, where do we start? And that comes back to the fundamental question of what are we trying to protect in the first place? So English ivy being a bushland weed and a very destructive one, it might be, okay, it's a major threat to biodiversity assets, not necessarily a major risk to farms. You generally rarely see it on farms, it's on roadsides and in bushland. So it would be, okay, well, we have, I would look at it is you've got a management unit and there's very little English ivy in one part of it. then perhaps work from that area and work out and push back and protect a community of plants, an EBC that doesn't have the English ivy, but it's capable of establishing. Or it might be a location of some important rare or threatened species of native plant, work in those areas, because at the end of the day, we'll never get rid of it completely. And so we have to move back into an asset protection mode and protect the things that are most important to us. So, and that's the sort of thing that we do pretty well every day. We may not articulate it in that many words, but that's what happens. That's the sort of process we're going through our minds generally.
And Robin, can I ask how, so say you've got, let's say for instance, a school site with surrounding bushland, how many years management, if you start in the good areas and work out, which is a general principle, have you seen instances where it has been eliminated from the system and over
Absolutely.
what time scale?
Yeah, absolutely. Yeah. So as a practitioner, we deal with English ivy a lot. And so the difficulty is with English ivy, if we can take that as an example, it's got the aerial component where, you know, it climbs up trees. That's when it starts producing seed. They're really easy to take care of, just cutting those aerial stems and the thing fizzles out. But the hardest part is the kind of dense mats of leaves and stems that you have on the ground. And with time, that's all you end up with. All your biodiversity is lost essentially, except for a few long-lived shrubs that might be poking up through it. And in that situation where you haven't got too many native plants present, it is possible to remove it using a number of different methods, but it's labour intensive and involves ultimately, end of the day, the use of herbicides and in a particular way, not just a foliar application of herbicide doesn't cut it. It needs to be a particular recipe, which if anyone wants to follow that up with me after this webinar, I'm happy to pass that on. I'm not prepared to do it right at the moment, but it is possible to control that using the right herbicide method. Anyway, so going back, yeah, it is possible, absolutely possible. It's one of the, it's a species that, you know, it does have a seed bank, but it's not particularly long-lived. And as long as you can take those seeding aerial plants away from an area that you want to protect, you'll go a long way to protecting an asset from English ivy. Hopefully that answers the question. So the next part, and it kind of relates a bit to what we've just been talking about, is the containment approach. So containment lines are basically, literally, a line in the sand, or more practically, a line in the map. It could be a line or a polygon. And that is an area where the focus of control efforts is made. And the attempt will be to keep infestations of weeds out of that. So you can, if we can just take English ivy as an example, given that it's been brought up, you might have a bushland property.
We've just lost sound there, Robin. Not sure what's happening. It looks like you've frozen. All right. Robin, we might give you a couple minutes to reconnect. Whoop. If you can still hear me, Robin, if you don't mind jumping out and then reconnecting. This seems to be the day for Zoom problems and tech problems, so please bear with us, everyone. Sorry about this. While we're waiting for Robin to rejoin us, I might ask...
Will we throw back to Ray?
Ray, try Ray again.
Oh, let's go. We've got a backup plan too. So let's we'll see. I am loading just my PowerPoint presentation this time. So I am hoping that that comes up and you can see that.
Yay!
Let me know when you can see it.
All good.
Yay. Okay. Well,
Yeah.
I did start by saying that yakandanda meant two rocks in a creek, but it also means the internet connection is pretty bad as well. So let's get on and talk about biocontrol of weeds. And to be honest, it actually is a good segue from the previous kind of presentations, because biocontrol of weeds is really appropriate for those widespread weed infestation. So we're talking about the regionally controlled weeds that I think Robin and Luke, who was talking first, sorry, I haven't got my agenda on with me. And if you are having trouble hearing me, just wave, because I can see you, Caroline and Joe, on my screen. But excellent, good. Okay, so let's get into it. Biocontrol of weeds. So I should say that I am Raylene Kwong. I am the invertebrate and weed science. I work within the invertebrate and weed sciences group within Agriculture Victoria, and I lead the biological control of invasive species group, which is largely based at AgriBio, which is on the Latrobe University campus. And we look at biological control of weeds and also invasive pests. I'm going to just talk about biocontrol of weeds today, and it is a large topic. So I won't be able to obviously cover everything. So if you've got questions along the way, please feel free to ask. But in a general sense, biocontrol is the use of natural enemies of, in this case, we're talking about weeds. So natural enemies of the weed. So different to, say, the cane toad incident, where people often say, oh, well, that's a bad case of biocontrol. Sure, it used a natural enemy, the cane toad, to try and control a pest, being the cane borer. But in this case, and it's a bad example of classical biocontrol, we never say that was a classical biocontrol program. In the case of classical biocontrol, we're looking for natural enemies of a pest or weed that has co-evolved with that pest species. And so they're target specific. They only feed on the host that we're trying to target. So that's the distinction between just general biocontrol and classical biocontrol. Co-evolved natural enemies, we aim to reunite them with their host. So as you know, a lot of our pest species they're exotic, they come from overseas. We're looking for those natural enemies that co-evolved with those pest species in their native environment, in their native range. And so a lot of the research that we do is looking for those natural enemies and introducing them into the country to bring the weed population down to a manageable level. So we early on saw an image of the invasion curve. When weeds come in, they start to proliferate, they get out of control. When they get to that widespread, difficult to control kind of stage, generally that's when biological control becomes the last resort. So in this image, you can see how the weed populations, they fluctuate from year to year, season to season. When we introduce the biocontrol agents, the aim is for those the natural enemies, we call them biocontrol agents. The aim is to attempt to reduce those weed infestations to below what we say is a threshold. That might be an economic threshold if it's an agricultural weed, or it could be an ecological threshold if it was, say, an environmental weed. But we're trying to reduce it basically down to a level where it's not as problematic. Now, it will never eradicate the weed, and that's why it's important. Well, it's important to know that biocontrol just does not work in that way. So there's lots of success stories with biocontrol, and here's a local one to Victoria, and this is Patterson's curse. This photo in the top left is up around northeast Victoria, near where I live. It's actually out near Tallangatta, near the Hume Dam, and this photo was taken about 20 years ago, before the biocontrol agents were released. And then I went back to that site just a couple of years ago, 2018 actually, and took another photo. You can still see the shed's still there. There's a couple of more shipping containers that have arrived, but the Patterson's curse is largely not there. Now, it's not eradicated, and some years we do see Patterson's curse back again. And in actual fact, the last couple of years we have seen a resurgence of Patterson's curse. And that's largely because of the environmental conditions, particularly where we have a fairly dry summer or late autumn break. Those kind of conditions can hamper the ability of those biocontrol agents to survive. It might reduce their populations, and then the weed, Patterson's curse, will resume again. And it takes a year or two for the biocontrol agents to build back up again and bring the weed population down again. So it demonstrates that cyclical kind of event. In the Patterson's curse program, there were a number of different biocontrol agents released. In fact, there was over 6, I think, and each one of these attacks different parts of the Patterson's curse plant. So there's a few that attack the roots. There's a beetle that attacks the stem, and then a moth that attacks the leaves, and a little beetle that attacks the seeds. So it's a combined attack of different natural enemies that are attacking different parts of the plant, and that's why this particular program has been quite successful. They're not always that successful, though, and there are lots of different reasons for that. So, for instance, there may be parts of Australia where Patterson's curse is still a problem, and that could be because these particular biocontrol agents may not be working that well in the particular climatic conditions of that particular area. It could be that there are genetic differences within the weed population. So, you might see a weed, say Patterson's curse, and think that, it's all the same, but there could be different, what we call genotypes. If you think of, ancestry.com, for instance, humans can be one species, but there are different, relatives, and you can work that out through genetics or DNA. We can do the same kind of thing with weeds, and we are starting to understand that weed populations are not all uniform. And because we're looking for biocontrol agents that are highly host specific to our weeds, sometimes they're so specific, they can be specific to a particular genotype of a weed, and that another genotype might escape attack. So these are some of the things that can influence the ability of a biocontrol program to be successful. So how is biocontrol implemented? Well, there's a lot of work that happens behind the scenes prior to us even having a biocontrol agent available for release. And this is all the work that's done overseas in the native range, looking for what natural enemies might be suitable for a biocontrol program. So say, for instance, in the case of Patterson's curse, there was over 60 different natural enemies that attack Patterson's curse in Europe where Patterson's curse is native. We need to work out which of those natural enemies might make good biocontrol agents. When we then have worked out that, we prioritize that list of natural enemies. We then have to import them into a quarantine facility, such as the one that we have down at AgriBio in Melbourne. It's there that the natural enemies will undergo stringent testing, which we call host specificity testing. It's where we expose plant species, and these are usually crop or ornamental plant species that are closely related to the target weed. We expose our biocontrol agents to those other species to see whether the biocontrol agent can attack them or not. Do they feed on them? Can they lay eggs? Can those eggs hatch? Can those larvae or immature stages develop all the way through and complete a life cycle? So it's a series of tests that are done, and quite often it can take at least 3 years to go through that process of testing. And depending on what the weed is, will depend on the extent of the testing. So we may have to test over 100 different plant species. If it is a weed, that might have lots of closely related, economically important plants, crop plants, ornamentals and things like that, or lots of native species. If they're closely related to native species, we have to test those too. So all of that work is done behind the scenes. You often don't get to see any of that kind of work. It's usually done in a quarantine facility, and also some native range studies are done overseas as well. Once we have completed that testing and the results of that testing show that the natural enemy is specific to its weed target, all of that information then is put together in basically a risk assessment document, which goes up to the federal government. They then review it in detail. Again, their review can take sometimes over a year, where they scrutinise the results. They then send that that information out to all of the states and territories, to the to relevant government agencies, also for review. When all that information comes back, then the federal agency, which is Department of Ag, Forestry and Fisheries, DAF, they will then either approve or not approve the biocontrol agent based on whether they believe it's going to be safe for release. And then once it is safe for release, then it comes out of quarantine and we undergo the mass rearing and release phase. And that's when we have the biocontrol agents available for release for implementation. And we do a lot of that work with community groups, landholders, and stakeholders, depending on what the weed is. So that might be irrigation companies if it's an aquatic weed, or landcare groups and things like that. So I'm just going to run through a couple of the projects or weed targets that we are currently working on, and the different kind of phases that they're in. So at the top here, these are the basic, what we call the biocontrol pipeline, the phases of research that you go through from exploration to risk assessment to implementation. Greg LaFoe is one of our staff. He has just actually completed his PhD while working in biocontrol, and he was looking at natural enemies for silverleaf nightshade, which I would doubt you've got silverleaf nightshade in your region, but it certainly is a problem up through central Victoria and kind of like the drier areas. So he's been looking at potential biocontrol agents for this weed in South America and around Texas. Tradescantia, we have been doing some and completed the risk assessment on a beetle called Neolema. So we have an application for release currently being assessed by the federal government. Unfortunately, we don't have any funding at the moment for this particular project. The funding came to an end. So we're hoping to rally around hopefully some council, local government might be interested in kicking in some funding as well. If we get this biocontrol agent approved for release, it would be great to rear it and release it. There is another biocontrol agent that has been approved for release, work done by CSIRO, which is a fungus, and that has been released at some locations in Victoria as well. But it's currently not being mass reared and released. Again, that program is finished by CSIRO. So it might be an opportunity to redistribute the fungus from locations where it's established to other locations if you have Tradescantia, wandering trad, in the region. Blackberry, this is a program that has been going on for a long time now. Blackberry, the biocontrol started back in the 60s, and there was a fungus, the rust fungus, that was released. And you can see in this particular picture, I'm not sure if you can see my mouse moving on the screen. If you Yes, you can. Good. Okay. It's always hard to know what you're looking at. And this is a classic photo. It gets used a lot, and because it shows that there are different patches of blackberry here that are being affected at different degrees. So this patch in the front is not being affected by the blackberry rust at all, whereas the one in the background, which has all of the brown leaves, is being defoliated by the blackberry rust. And this is a classic example that demonstrates that blackberry in Australia consists of lots of different species, but also lots of different genotypes, and genotypes that some are resistant and some are susceptible to the rust. In fact, it's likely that a lot of the blackberry that was susceptible to the original rust has been displaced by other blackberry that is resistant to the rust. So we have started a new program of looking at other potential natural enemies for blackberry. There's been a lot of genetic work done on blackberry taxa to try and understand what are the different species of blackberry that we have in Australia. And we're using that information then to refine where we need to go to look in the native range of Europe for new biocontrol agents for blackberry. One of those is a cane boring sawfly, which you can see here. The larvae of this, so the adults, and they're all mostly all females, they don't actually require males to breed. They just lay an egg into a blackberry primer cane, and that caterpillar or the larva bores up and down the cane and damages the primer cane. So that's the first year non-fruiting cane. But there are a whole raft of other potential biocontrol agents or potential natural enemies that occur in the native range that do attack different parts of the blackberry plant. And so in this new project, we'll be looking at whether any of those particular natural enemies might be suitable for introduction into Australia following their host specificity testing. That's very exciting. Okay, this is a very, very busy slide because I've lumped 3 weeds in here. These are some newer programs where we've got new biocontrol agents that have been approved for release over the last few years. So African boxthorn, there is a new rust that has been introduced that is work being done by CSIRO, but in a new project that we have funded through the Future Drought Fund, coordinated by the Centre for Invasive Species Solutions, we will be introducing the rust into Victoria at strategic monitoring sites. So if you do have any large boxthorn infestations that might be suitable for rust release, please let me know. We're looking for some sites. Sagittaria is an aquatic weed. I don't believe there may be one infestation that I think was under eradication, but certainly up in northern Victoria, southern New South Wales, this is a problematic weed getting into our irrigation channels and also some of our sensitive habitats like the Barmah forest, gumbow forest, some of our wetlands. So it's a horrible, horrible weed. I just did my PhD on this, actually it was nearly 10 years ago now. And we're introducing a little weevil, this tiny little thing here that feeds on the fruit. Horehound, I don't know if you've got any horehound in your area, but we have, there is a clearwing moth. The larvae of this moth feed within the root system. It's not actually a new biocontrol agent, but it's only got limited establishment in parts of Australia. So in this Future Drought Fund, we're trying to redistribute this moth to other areas where horehound is still problematic and not under control by biocontrol. English broom and Cape broom. Look, these are 2 projects that we're really not doing a lot of work on at the moment, but there are some biocontrol agents out there that are doing some really good work. So there is a galling mite that forms these galls on broom, and there's also a seed-feeding beetle called a bruchid. This photo was taken out at Dartmouth, up in the northeast. But Cape broom also is another, well, it's a related broom, but there is a psyllid that is starting to do lots of damage. These photos were taken in Tassie, and it builds up really quickly and does damage Cape broom pretty quickly. So again, we're not actively distributing it, but it could be an activity that could be done by community groups if they do have Cape broom or Montpellier broom out in their areas. Gorse, again, a bit of a legacy project for us, but there is a moth called the soft shoot moth. Has only really been released at several locations in Victoria, but could be redistributed more widely if people are interested in that particular insect. We're currently doing a project looking at genetic diversity of gorse across Australia. and the native range to see if there are genetic reasons for why some of the biocontrol agents aren't establishing at all of the locations across Australia. So we will also be looking for some gorse populations in various locations in Victoria. So if you do have gorse in your particular area, get in touch, because we could include some of your gorse populations in this genetic analysis. Spear thistle and variegated thistle, haven't got a photo, but these are pretty old projects, work that was done through the late 1990s, early 2000s, and 2 biocontrol agents were introduced, particularly for spear thistle. The first one is a fly, and the second one is a weevil. Both of them attack the fruiting heads and basically feed within that tissue and reduce the seed production. So have a look on your thistle heads during spring. This particular fly, Europhora, I reckon it's pretty much widely established. This little receptacle weevil, I don't believe is as widely established, but I reckon they're pretty established down in Gippsland. So have a look for those. If you actually look for your spear thistle at the moment and look for some dead heads on the thistles, wear some gloves, some leather gloves. Get a pair of secateurs, cut the heads in half and open them up. If you feel like that head feels like it's got a really tough, like almost the size of a marble, and it's really firm, you cut it in half. If you see some little grubs, they are the grubs of either the spear thistle or the receptacle weevil. So that means that you'll have those biocontrol agents there. That's a good telltale sign that you've got them. Ragwort, again, another project that was done back in the 90s, early 2000s, and various biocontrol agents have been introduced over the years. Actually, I reckon it started around the 1960s with the introduction of this cinnabar moth caterpillar. Cinnabar moth never really established in Australia. But these other insects, there's a plume moth, there are 2 species of flea beetle which feed within the roots, and a crown boring weevil moth. Sorry, these were all released into Victoria and have established at some degree or another. Now, these before and after photos were taken in Tassie, and we have not seen the same level of control in biocontrol in Victoria on ragwort. Again, it could just be climatic reasons, it could be genetic reasons, we're not exactly sure, but we do know that some of these biocontrol agents have established and built up. What you need to look for flea beetles are these tiny little brown beetles, and they cause these shot hole damage to the leaves. But you'll find the larvae, I'm not sure if you can see them, but there's tiny little holes. The larvae of these beetles are in the roots. That's where they do the most damage. So look for these in spring. The other 2 moths, the larvae of these really bore up and down the stems or can be found within the crowns of the plants. That's the center part of the rosettes. So break them open, the stems, during summer, and look for larvae and kind of tunneling damage within the flowering stems. And that's a sign that you would have either or potentially both of those insects there. But having said that, though, if ragwort is still a problem and the biocontrol agents are there, then clearly the biocontrol is not giving you the level of control that you need. So you would need to be looking at other forms of control if you want to get the ragwort under control and the biocontrol agents just aren't doing enough for you. So moving on to resources, because there are a lot of different weeds that have biocontrol agents available for them in Victoria and southeastern Australia. I can't talk about them all today because we'll run out of time, but there is a fantastic resource, and I'll email through the PDF of this book to you so that you can have a look. But because it basically covers all of the weeds, except for some of the really, really new ones, on biocontrol, and really useful information about how to go about looking for the biocontrol agents, how to identify them, and how to go about collecting them and to redistribute them. If you don't have biocontrol agents in your region, but you know they might exist elsewhere, you could then work in with say another community group to help redistribute those biocontrol agents from one region to another. So we do a lot of that work with community groups, particularly up in the northeast, only because I live there. And I know a lot of the community groups personally, and I think they might even have a one of the Partnership Against Pests program. I think they do a lot of redistribution of biocontrol agents through some of that funding. Another resource is the Australian Biocontrol Hub. This is a website that's hosted through the Atlas of Living Australia. So if you're familiar with the Atlas of Living Australia and any of those kind of citizen science type projects, there is a project in there called the Australian Biocontrol Hub. There is also an app you can see there that you can download onto your phone. And that hub or the app allows you to, it has all of the, most of the biocontrol projects on there and the biocontrol agents that have been approved for release. And then you can use this app to work out things like where have the biocontrol agents been released or seen, or you could record your own biocontrol agent monitoring. So if you see biocontrol agents on your property, you can then take a photo and upload it to that particular project. The hub itself is currently or just about to undergo an upgrade. So I don't know if that means it's going to be taken offline, but there are a whole lot of new projects that need to be added, and we're trying to make it a little bit more user friendly. I find it a little bit clunky to use. But when that is updated, that'll be a fantastic resource. And this is just an example of the Patterson's Curse biocontrol agents that have been released in Australia that have been uploaded onto the hub. So it shows you, a good location of where they all are. But I think in the new version of the hub, they will also be able to overlap the weed infestations. And so then you can see where biocontrol agents are as opposed to where the weeds are. And then you might be able to go, oh, look, there are actually none of those biocontrol agents were released in my area, or nobody has ever found them in my area. It might be an area that they haven't reached yet, or they haven't been released. That might be an area where we could target for biocontrol. So that's just how we're using that. So pretty much in conclusion, I guess I tried to say this, that biocontrol is, it's never going to be a silver bullet. It's really only appropriate for those widespread weeds that are not under active control, through eradication and whatnot. So it needs to be looked at as an integrated approach. And Robin did talk about, that aspect of integration, the importance of that. So it might be that there are areas of the property or the region where the particular weed may be in an area that has low value for control. It might be an area that's really difficult to get in there and control, or where the use of herbicides or other techniques just aren't feasible or aren't economical, or may cause off-target damage to other species. Some of those areas are more suited for biocontrol. But for those agents that have been out there for a while, they may be appearing in your paddocks, in your pastures, on your weeds. And okay, they're there, but if the weed is not controlled to a level that you're happy with, you may just have to do something else to help them along. It may mean that you have to go in and spray, for instance. But the biocontrol agents are in, they may be widely established, and they can just move back in from other areas. So that's also possible. In our group, agriculture, in the biocontrol group, the way our funding works is that we're funded to work specifically on projects that we're contracted to. It means that our small group quite often can't necessarily help on other weeds for which we don't necessarily have funding on. So say, for instance, ragwort. It's not a project that we currently have any funding for to do biocontrol. It means that if a landholder rings up and says, I want to get biocontrol agents for these, or can you come out, we're limited in being able to do that. And that's where we really want the landcare groups and community groups to tap into programs like potentially the partnerships against pests, where they could be putting up a application that looks at integrated control of a weed, for which biocontrol might be one part of it. In that particular case, then we might be able to help you then provide, training or information on where you might be able to source the biocontrol agents for, or you might be able to, involve us in, say, running a field day where we could go out and monitor the biocontrol agents. But unless these are part of projects, we're really limited to be able to provide that kind of general assistance, unfortunately. A lot of our focus in our team is on the research aspect of it and looking for new agents, undertaking the host specificity testing, mass rearing and doing initial release. But once those biocontrol agents have become established or, in areas but may require redistribution, that then becomes an on-ground activity, which we generally rely then on community and other land managers to help do that work. I think I'll leave it there because that is my last slide. So do you have any questions?
Ray. Thank you, Ray. We are running over time, everyone. So if there's one burning question, we'll field that. But otherwise, if you could pop your questions for Ray in the chat, and we'll make sure we get back to you with answers to those. So
Yep. Sorry for going over time, but there's a lot to cover. It's hard to do it in 10 minutes.
Sure is.
Or half an hour.
It's only me who put a couple of questions in the chat, but we should keep running on. So Ray, if you're just able to pop into the chat and have a look at my, I always say there's no such thing as a silly question, but I believe I may have asked the obvious ones. And we might throw back to Robin.
I'm sorry about that dropout. What actually happened is the sun was shining on my portable device and it overheated. So I put up a little shade screen so that shouldn't happen again. So yeah, thanks Ray for a great summary on biocontrol. We were talking about measures of success, and we covered prevention, eradication, and we're just about to get into containment. So that's another step up in the invasion curve, and it's something that we probably do without really thinking about it, but it's where a line or a polygon is drawn and that becomes the focus of attention. The polygon might be an area of bushland on a farm, for example, that doesn't have English ivy. We're using that because it came up in discussion. But English ivy is pretty well everywhere else. So the containment approach will be to, because we've got limited resources, just to focus on keeping ivy out of that polygon and keeping that free, but knowing very well that, there's a sea of it surrounding the area that we're interested in. We kind of pushed into that situation a lot when we have weeds that have got a big distribution but haven't quite filled it yet. And it's a good way of using limited resources. So that approach has been used, for example, at a national scale for bitter bush, where a containment line was literally marked on the southern boundary and northern boundary, and a lot of attention was put into controlling bitter bush infestations that went past that boundary. So that was good, for example, for Victoria, because the southern boundary was around Eden, and but bitterbush has potential to definitely get into coastal systems in Victoria, and that hasn't yet happened. So that approach is also being used, for example, with myrtle leaf milkwort in Western Victoria and coastal tea tree, for example, in Discovery Bay National Park, where significant weeds with a limited distribution, capable of going a lot further, and lines have been put in place, literally lines on a map, and said, okay, anything past this line, we're going to put resources into. The only problem with that approach, but sometimes we don't have any choice on using it, is that should our attention lapse for whatever reason, change in personnel or a change in budget, and that the weed gets a head start, then we've lost our advantage, and we then move into the next phase of control. But just going back, a measure of success, because that's the topic of this discussion for containment, is that we get no new infestations, or all infestations that we detect are treated in that within that containment line. And that's a pretty convenient and objective way of doing it, providing we've got good mapping information. I'll just make a point of that. With any of the methods that approaches that we're using, eradication, prevention, containment or suppression, mapping and knowledge of where the infestations occur are absolutely critical. If you don't have that right in the beginning, then it becomes very difficult to do anything effective on the ground. So a lot of weeds that we're probably dealing with are beyond eradication. Prevention's not worthwhile. We can't do it. It's already there. Containment is not possible because the species might be widespread in our landscape unit. So we're looking at suppression, and this would be by far the most common method of control that we all undertake at a practical level, whether it be National Park Service or farmers or Landcare Group, and it's applied to widespread and established weeds. And the objective here is essentially to reduce the density of those weeds and therefore their impact. So the impact can vary depending on the situation we're in. Like in a farm, it might be, the impact will be the carrying capacity of a paddock, the number of cows that you can graze in a paddock. And weeds, for example, blackberry or ragwort, can impact on that. It might be loss of biodiversity, for example, invasions of game of blackberry or English ivy or broom. When the infestations become so dense and so widespread, we most definitely see a loss of biodiversity. Our herbaceous component, our shrub component, even tree regeneration can be affected when these weeds become particularly dense. Or it might be loss of access to a river frontage, a social asset, through blackberry invasion, for example. So the concept of suppression is bringing back densities back to a level that are acceptable. Okay, so eradication's not possible. We'll never get rid of it completely, but we're managing the weeds to bring it back to something that, okay, we'll live with it. And that can vary depending on the objective of the program and the species. For example, with ragwort, it might be the biomass of ragwort plants there that are below the toxicity threshold for sheep or horses or whatever that might be. Okay, so you haven't got rid of all of it, but there's not enough in there now to poison your stock. With blackberry, it might be the percentage of the farm that carries infestations or the number of infestations. So it might have been a paddock that was entirely covered with blackberry. You manage it, you reduce it, but you never get the whole lot. But now you can put stock in there and it becomes useful for production. With thistles, for example, it might be the number of plants per hectare that you're prepared to live with. And so with control programs, and as a practitioner, we often ask, okay, so the objective of this control program is to treat a percentage of the infestations, and we want all those infestations killed. And usually the figure that we're talking about will be somewhere between 75 to 100%. 100% is difficult to achieve in some situations unless it's a very limited distribution, and 75, it's a, you know, sometimes that can even be hard when you're dealing with a massive infestation with a plant that is capable of regenerating easily. So targets are important. We don't often discuss them, but in the commercial world, that's a given way of life, and it's a good thing to work to, because that is our measure of success. It determines our success for the clients that we work with. It determines success of weed management for the land manager. And it's a good question and a good objective to have before embarking on a control program. You've got an objective in mind. We know that we have to get 80 to 100% of the infestations, and that will determine the methods that we use to undertake the control program. So a proactive approach to establishing what the measures of success are, I think, are really important, and it's something that we probably need to articulate a bit more often, keeping in mind the methods that we might use. So that's all I've really got to talk about on that subject, Jodie. Unless there's any questions, I'm happy to try and answer those.
Thanks, Robin. We do have some time for questions. If anybody has any curly ones they'd like Robin's advice on. We've covered off on ivy, but I know there's a few of us online battling ragwort and a few other weed species. Just unmute yourself and ask away. Taking silence, there's no questions. We have had a question in the chat while you've been chatting, Robin, about biocontrols for ivy, and Ray's kindly answered and said, unfortunately not for English ivy yet, but K5 there is. We're still doing some host-specific, I can't even say that word, host-specific testing. I guess, Robin, while we've got you online, if you wouldn't mind sharing some of your experiences on some of the worst infestations of particularly ragwort, blackberry and thistles. Is there any tips you could share for those?
Definitely blackberry. Not so much ragwort, but I'll touch on that a little bit. You know, I've got to be honest. Blackberry is not a particularly difficult plant to suppress or kill. It's actually one of the easier plants to manage. I can hear people thinking, well, that's not my case, you know, but if the right chemicals at the right time with the right management methods, whether it would be fire or mechanical, whatever, blackberry is, in my experience, one of the easier plants to kill, because we have some highly effective herbicides, for example, that can be used to kill it. The problem with blackberry, and it's why it's still a weed of national significance and causing everyone difficulty, is the extent of the infestations and where they occur. On farmland, blackberry can be managed relatively easily, providing access is available. But our bad infestations generally occur in areas that have poor access. And if you go to pretty well any national park or nature reserve in East Gippsland or the Highlands, for example, blackberry will be well and truly entrenched. And despite having biocontrol in place using the blackberry leaf rust fungus, in many of those situations, the rust fungus is not effective, primarily because blackberry is underneath a canopy of trees. And in that situation, blackberry plants, believe it or not, tend to be stressed. They don't grow as fast. They don't put on as many new leaves in the growth season, and therefore the rust is not able to build up into epidemic type levels that lead to defoliation, which can lead to weakening of the plant. And that is the primary reason why Ray and her group are looking at additional biocontrol agents for blackberry, because the rust tends to have very limited capacity. In the right situation, in the right year, with the right kind of rainfall parameters, rust is a fabulous control method. And it has been very effective in suppressing blackberry over large areas in some years in some places. But there are many, many areas in Australia where biocontrol is not working. So, and they're difficult. It's one of the more difficult areas to work because, again, we're very limited in some of the methodologies that we can use to tackle blackberry. For example, it's widespread in a national park because of the non-target impacts that might occur with the use of mechanical equipment, fire, or herbicide. But on smaller properties, when we do a lot of work on those, we've had, and it is possible to achieve success pretty easily, providing access is there. And the key component to it is persistence. We never expect, and our advice is others shouldn't expect to be able to eliminate blackberry in one season, because it won't happen. Because even though you might be able to remove the tops, the plant will regenerate from bits that have been missed, or from a soil seed bank, even though that's fairly weak, or from parts of the crown that just weren't fully killed with any method that has been applied in the first round. But with time and persistence, success is definitely possible. And literally, we just need to stick with it and be more patient than the weed. And sometimes that can take a very long time.
Thank you, Robin. And I think that goes back to your comment earlier today about seed banks in the soil lasting beyond a decade in some cases. I do have a question here in the chat with regard to the use of grazing as a control method, particularly with blackberry. When and why would you use that? If you could elaborate on that, please.
Well, whoever asked that question, thanks. Great question. In simple terms, absolutely. Some animals, some more than others, eat blackberry. Cows, sheep, horses, they have a bit of a nibble on it. But at the end of the day, blackberry will surpass their capacity to eat blackberry leaves or stems. But we have one grazing animal that is a great herbivore, and that's, of course, the goat. Goats have an appetite for blackberry. They're passionate about blackberry, and they'll graze that above a lot of other plants in many situations, and they will graze it basically back to the stump. And the Blackberry Task Force has sponsored work on goat grazing trials in the Yarra Valley, where a mob of trained goats, these are goats that are trained to stay in their fence and not try and get out. The ones that do get out end up in the cooking pot. So there have been biological selection for goats that don't want to escape. What they achieved was nothing less than remarkable. Of course, there's limitations and constraints with goats, because once the blackberries have been removed, of course, goats get hungry and they'll start grazing on other things, and they will be whatever's around it, whatever woody material might be there. And it could be the bark off gum trees or wattle trees, and they will most definitely start causing undesirable impacts if they're not taken off fast enough. But once that foliage canopy of the blackberry is removed by grazing, provides access, we can actually get into an area now, and then you can start applying other methods, whether it be spot spraying with herbicides or mechanical methods or shading. There's a whole range of methods that are available. These are all outlined in the Victorian Blackberry Control Manual. If you haven't got that, have a look at it. There's some great information in that that's available online if you have a look at the Victorian Blackberry Task Force website. So
Thank you. Thank you, Rob.
grazing is a great method, yeah, in some situations. Yeah.
Is there an issue with goats or any other animal grazing on berries and dispersing the seed that way, or does the digestive tract kill the seed?
Oh, yeah, look, I can't think of any information, publication, studies that can confirm or deny that. It's quite possible that, you know, you're going to get seeds moving through the gut of the goat, just like any other herbivorous animal. Rabbits, for example, still pass viable seeds of some plants. So it's quite likely to happen with goats. I'm just not.
Oop, I've lost sound. Has anyone else lost sound?
No, no.
No, I would think we've just lost Robin again.
Okay.
He's overheated.
Thank you, Robin. If you can still hear us, if anyone has questions for Robin, please pop them in the chat function and we'll follow up with him. While we let Robin cool down, we'll pass to Ben now from BioBloom, who will chat a little more about what weeds are telling you about your soil. Some very interesting stuff. Thanks, Ben.
Awesome. Thanks for having me. Let me share here. Hopefully we don't have too many hassles. Have you got my presentation up, the title page?
Certainly do.
Wicked. Well, yeah, let's rock on. I guess we'll change tact a little bit, and I totally understand everyone's been hanging in for a minute, so I'll try and smash my stuff pretty quick. And if anyone is interested, feel free to get in touch with me after the presentation. Happy to talk about this stuff all day. But yeah, I'm Ben from biobloom.au, and I also do a little bit of work for the Yarram Landcare network. I'm an environmental scientist, and I'm interested in ecological interactions. Today, I'll focus on weeds as ecological messages and their place in the ecosystems, and species like blackberry, ragwort, thistles, and gorse, which are some of our more common ones around Gippsland. How they can tell us stories about what's happening in the soil in both pasture and restoration contexts. Ideally, rather than treating weeds just as pests, I want to highlight how they're the soil's early warning system for signals of deeper issues and how we can respond in ways that build healthier and more resilient landscapes over time. So why look at weeds? We've got some, pretty standard ones. And as we've looked at them over the years, they generally seem to occur in pretty similar places. Blackberry will often choke out gullies and creek lines. Ragwort is often in pasture, especially in dairy country, heavily chemically amended. Thistles will often occur clustering in areas of high traffic, whether that be mechanical or animal traffic. And gorse will often infect kind of neglected little corners. I'm not sure if you can see my mouse there, but I'm kind of waving around. I'm probably waving around too much. It's a bad habit.
We can see it, Ben. All good.
Awesome. They can be frustrating, no doubt, but they're each signposts. Each one is thriving at that time in that place because the conditions suit it better than other species. Blackberry, for example, loves over-fertility and moisture, so you'll often find it in the watercourses. Ragwort flourishes where soils are run down and nutrient depleted. Thistles take advantage of compacted ground, and gorse digs in where management pressure is low and nutrients are imbalanced. When we look at them this way, weeds aren't just problems, they're actually messages in the soil, kind of like a bit of a dashboard warning light system from the ecosystem. They can tell us about compaction, acidity, nutrient imbalance, neglect, before any of those issues can spiral out of control. And I think the big point to remember is that ecosystems are never static. They're constantly in flux and they shift in response to their environmental conditions. The disturbance of either the environment and weather or human animal disturbance, as well as our management implementations. And that dynamic nature is actually our advantage. So if we understand what's driving that change, we can use disturbance intentionally to reset conditions in favour of species that we want, and we can create ecosystems that are balanced in a way that allows them to spread that balance further, similar to what Caroline was talking. Caroline and Joe mentioned earlier about starting in small areas and working outwards. In ecological succession terms, the weeds are generally pioneer species. They colonise first to stabilise soil and stabilise bare, compacted, degraded ground generally, and their presence is part of a natural sequence. If we look at them just as pests to eliminate, we miss an opportunity. But if we read them as ecological indicators, we can unlock a new perspective. And suddenly every weed patch is an opportunity to ask, what's this telling me about the soil? Reading that signal and acting wisely will hopefully guide us to a more diverse and productive system. So it does require a shift in perspective, but that shift is really quite powerful. And it means we can respond in ways that don't just fight weeds the day you're fighting them, but will help to build more resilient landscapes over the long run, where weeds lose their advantage of being able to pioneer into disturbed and degraded ground. So we'll specify down a little bit now. When we ask why here, why now, we uncover the processes that drive the weed spread. The species aren't random. They're niche as pioneer species, means they're highly tuned to the signals that the environment is sending. And as I've said, you can see in the photo here, often in the gullies, you'll find blackberry, and there is a bunch of thistle here along this path as well. So the weeds will generally keep popping up in similar places, so we can use that knowledge to identify what those places are lacking or what other things we can add that provide similar services. So blackberry's deep rhizomes exploit the nutrient enrichment and high soil moisture that occurs in those clog gullies, and it's generally signalling a nutrient accumulation that's potentially running off your paddocks in the form of unused fertilizer or eroded topsoil. So these are things we really don't want to run out of our paddocks. So the blackberry is really giving us a great signal there that there's an overload or a nutrient imbalance within the nearby landscape, and controlling that nearby system can help to control the blackberry system and allow that to be less competitive in its space. Moving on to ragwort, Jacobea vulgaris. I always think that's a pretty cool Latin name. But it thrives in acidic and low fertility soils, and it's often found in long grazed dairy paddocks. It tolerates low calcium and phosphorus, which if you've seen an agricultural soil test, they're often the things that come up, and high magnesium, which ragwort will also tolerate. It also produces an allelopathic compound, which is a funny word, but it just means a compound that a species produces that suppresses species around it. So what the ragwort is trying to do, it is trying to create itself as the biomass for the soil to recycle and create a system in the future, but it's the seed bank's best option at the time. It expands where overgrazing has reduced the soil health, and it signals fatigue and overgrazing stress. Thistles, again, guys, these are very much rules of thumb. Each ecosystem deserves to be assessed in its context, but these are some things that you can use as starting guides. Thistles are disturbance specialists, like I said. They colonise your compacted gateways, tracks, stock camps, around troughs, things like that, areas that have really high traffic. And they're able to do that because their tap roots are really deep and quite strong. And they'll push through that hard compacted soil pan that's created on the top. And also their wind-borne seed bank, the little purple top that you see often on a thistle. That's the Scotch thistle is a common one in Gippsland, but there are many other varieties. Often have a really dense and wind-borne seed bank that allows them to exploit bare soil quickly. So we have a pet pig. He will often dig holes in his paddock, and often thistles will be there in, rapidly a day or two later. So they're really expert at colonising those quick bare patches. And their presence signals compaction, disturbance, and a loss of that ground cover. Gorse is one we're experiencing a little bit more in Gippsland at the moment, probably slightly, probably lower on the scale of what Robin and Ray were talking about earlier, potentially still in the controllable, eradicatable stage in this area. But it is a nitrogen-fixing legume, adapted to poor, shallow soils, especially on slopes and where fertility has been lost due to erosion. It forms dense thickets in low management corners, and it capitalises on its nitrogen-fixing ability and a really long-lived seed bank, which I think Robin mentioned as well. Gorse signals neglect and an underlying fertility decline. The bigger picture is that weeds aren't just random pests. They are the environment's ecological indicators. They can reveal soil chemistry, hydrological shift, and management pressure and stress. And if we can interpret them properly, they can tell us not just where problems exist, but also which problems are solvable and the most useful to solve at the time, whether that be compaction, nutrient loss, erosion, grazing mismanagement. There's many different issues that could occur. But that perspective shift allows us to move from a reactive control system to more of an adaptive control system that relies on observation and the use of these different techniques that Ray and Robin talked about. And in that way, we can reduce the pressure through the long term. When we see weeds as the ecological messages, they point us straight to the underlying issues in our soils, as I've said. Blackberry, when it dominates creek lines and gullies, it's telling us there's excess water and nutrients, often from poor runoff or drainage. And the regenerative response would be to stabilise those creek banks with deep-rooted and shady natives, repair erosion, and build dense ground cover. That doesn't just suppress the blackberry, it can restore the hydrology and the nutrient imbalance that are the things that the blackberry depends on. So in these pictures on the right, this is some plantings we did up in Hiawatha. And we just keyholed into the blackberry, really labour, non-intensive. And these native acacias and eucalypts now are starting to create enough shade to affect the blackberry and create some pressure there. So that's only 2 years old, that planting, and it's already showing really great results. And there's plenty of scientific literature on the benefits of this suppression ecological keyholing method. Spreading radwort, to move on, is a sign of acidic, exhausted soils. Instead of just spraying the ragwort out, you can adjust the soil conditions to provide more organic matter using inputs like compost, biochar, cover crops, green manures to rebuild that soil fertility and biology over time. And it's the biology that's the really important thing. And over time, that shifts the competition back to healthy, productive pasture species. Thistles, we can use, the solution is to manage the grazing pressure and to manage the compaction. We can use some mechanical implementations. The Soil Key Renovator, if anyone's heard of that, it's a local Gippsland innovation, a really great way to amend that top layer of soil. And once the soil is active and biodiversely covered, thistles will generally lose their edge. A couple, like Robin was talking about, is something we can live with, and that's probably where we've got to be at the moment. The long-term response for gorse involves a mechanical control and reintroducing what the gorse is providing. So we need to reintroduce a leguminous nitrogen fixing species to do the job that the gorse is doing without the negative effect of the gorse. The gorse is going to be difficult to eradicate, but to provide that similar response alongside is the ecosystem balance response. Over time, you rebuild the soil, so it stops requiring the nitrogen fixing element that the gorse does provide. The big picture is that every weed carries a message, and if we read and respond to that message, we shift from endless weed control to trying to repair the system itself. Once the soils are functioning landscapes, weeds lose their competitive edge and are caught in their niche, which has been made smaller by the implementation of balance. When we zoom out, a bigger truth does emerge. Weeds aren't really the root problem. They're symptoms of deeper system imbalances, and they are actually acting as warning lights and showing us where our soil, water, and landscape management is under pressure. If we treat the weeds not as enemies, but as the messages, we can shift our strategy. And instead of yearly reactive control, we focus on systems repair over time. That means building organic matter and biodiversity, so pastures become naturally competitive and crowd weeds out. Correcting pH and chemical nutrient imbalances in a non-chemical way, and in turn removing the weak spots that weeds exploit. Relieving compaction with rotational grazing and deep-rooted perennial species, and thus maintaining continuous ground cover. And managing our water and drainage, so nutrients stay in the paddock and don't create hotspots in gullies and runoff pathways. When we can restore those underlying soil conditions, weeds lose that niche advantage, and over time the landscape can regain resilience. And these examples are now some 20 years old. If you look at the work of Charles Massey and things, we have really decade-long great evidence now of these processes working. In Gippsland, where we juggle dairying, forestry and restoration on some of the most heavily cleared and worked landscapes in Australia, this shift is critical. Moving from fighting in isolation to regenerating landscapes will help us to build healthy, productive and natural systems for the future. And I think, we'll struggle if we don't. So our mission is to keep the balance as humans. So some is okay. Every blackberry in a gully, every ragwort in a dairy paddock, each thistle in your gateway, or each gorse on the hillside. They're not just nuisances; they're actually lights and signals, and they're doing their best to help you help them. So I just thought I'd chuck a couple of cartoons in here as well to highlight how, we do have a responsibility a little bit as humans to give a little bit back. So thanks. I apologize for rushing through that stuff. I was trying to slam it pretty quick, but if you can, get in touch. Happy to have you on.
Thank you, Ben. It's a really important point to look at this. It really is a system out of whack, and we can see that by the changes since Europeans have come and changed the landscape, and we've introduced new systems and processes into a landscape that didn't have it for so long. Does anybody have any questions for Ben? Oh, I can see somebody typing in the chat. Just scroll down and have a look at that. Donna said thank you and love the perspective of shifting it as an indicator rather than just a problem to solve. We do have about 15 minutes left if you even wanted to share some of your experiences in addressing broader landscape process stuff and the impact that's had on your weed control. This is a platform to share your learnings with others, so I'll open the floor.
I'll just quickly mention too, Brian has mentioned in the chat there is usually mean to marshmallows, but I agree wholeheartedly. Its deep roots are similar to thistles, really great at punching through that top layer. And it is called marshmallow because you can eat it. A lot of these weed species, before I was an ecologist, I was a chef. So a lot of these things are edible. There's an amazing, an art installation / touring thing done by Mona in Tassie called Eat the Problem, which is really interesting. And there's a great book called Eat Weeds by Diego Pineri. Happy to chuck a link in wherever we chuck links. for anyone interested in eating some of this stuff. So yeah, some of it's pretty delicious. Get amongst it. Marshmallows included. Yeah, both tap roots and delicious.
Great. And Brian, you often I'm going to dob you in here because you're often talking about the rust and you wanting the rust to come through on the blackberries out in the Kawa district. Do you want to talk about the ongoing plight of blackberry rust?
I suppose I had been monitoring through the summer, and autumn was pretty dry out this way, and so I rather lost interest, and I will pick up on the growth once the blackberries are back growing strongly in the November-December time frame. That's when I'd expect to see the first signs of rust. But what to say? I haven't made much progress in terms of seeing patches reduced in growth and vigour this year.
Perhaps I can loan you my goat as well. Okay. Any other questions? Anyone want to chime in with some experiences and some wins, perhaps? You know, MD, who is actually Melinda, who has our massive ivy problem over there at Curramborough, has in the chat really got on control of the blackberry issue out there. So I think that really does deserve a big applause because you know, we're all fighting that fight and you've won that one. So next on your list is the ivy, and I'm definitely confident that you'll win that one as well. We'll get there.
I think some animal control there for that ivy is certainly worth a crack.
Yeah, I think we need to talk about loaning the goat out before she ends her. She's quite an old, lovely goat, but yes. So Donna, I've just seen your comment here. Would you like to have a chat and just talk to your comment that you've popped in there? I know you don't have a camera on, but microphone. No. Okay, so Donna's from the, I'm going to get this wrong, Leschenault Biosecurity Group in Southwest WA. We've had about 7 priority declared pest weeds in our area, including blackberry, bridal creeper, and a more recent addition, cleavers. The only biocontrol we promote at present for landholders in our area is bridal creeper rust. Is anyone aware of any other biocontrols for cleavers? Ray, that's perhaps for you.
Right, so good question. I do not believe that there is any biocontrol agents for cleavers available in Australia, but I think it has been the subject of biocontrol in other countries. I don't really know much more than that, really. I'll have to do a bit of searching to see what information is out there, but I don't think that there's one for cleavers in Australia.
Interestingly enough, my goat also really likes cleavers.
Oh.
I think she's just a little piggy.
Sounds like we need a roving band of goats to loan out.
Yes, I think that's a great idea, Joe. Excellent idea. So,
might invite Tyson, who works with Bauble Shire Council. Do you want to share any of the work you've been doing on weed control?
Yeah, so thanks. Carolyn Ferguson, who was my supervisor for a long time, she had a book, Why Weeds Grow, and I was going to mention that or ask if Ben had heard of that, but he's actually just walked away from his monitor. But that was something along the lines of the principle that he just explained with, they're all indicators. Weeds grow for a reason, like Doc with the taproot, same sort of situation as the marshmallow. breaks the crust of the surface, allows a bit of aeration, and allows that depth. And bracken and those sort of things, I know that's native, but from a pasture sense, the fertility then reduces that. So you don't need to address it with chemical if you're in a pasture setting. But yeah, what council does with weeds, we have a roadside weed control program that is rotational, targeting declared noxious weeds, but essentially through funding on roadsides, just blackberry. We do target thistle, ragwort, and broom, and very limited gores within our region on roadside, but we are aware that there's gores in forest within Baw Baw Shire, but it's not something that we actually maintain. And some of the previous speakers have mentioned the blackberries in those gullies, so that we're aware of areas of Allenby, Childers, and in the north, Newgee, and those sort of areas where there's significant infestations in those gullies. But yes, we try and just target the roadsides and help the community projects if there are community groups, and value add in those situations. And then we've got our general maintenance within our reserves that we do with a limited budget, but we also have a field team in-house that also do maintenance within our reserves. So that's pretty much where Baw Baw Shire's at. Are there any questions or?
Thanks for that, Tyson.
No problems.
It's certainly something that we've heard through all our conversations, is there's a lot of frustration about the apparent lack of control work. But I think one of the things that we've learned along our journey is that everybody is similarly frustrated with the weed issues, and resources are always limited. So having those friendly conversations with your local council contacts and land care networks is certainly important, so that we can work together and target the same areas rather than dispersing too thinly across the ground. There's just been a few other comments in the chat function. There's something about a Canadian paper on fungus control for cleaver, and also there's Robin chimed in and said there's certainly native insects over in the UK that do feed on that, so maybe there's worth looking into that. While we still have you online, I would love to ask you to spend just 2 minutes to provide feedback on today's session. This is something that allows us to, I guess, argue the case to funders that these sessions and bringing together these experts is really valuable. So if I'm just popping a link in the chat now, if you could click on that and just spend a couple minutes sharing your thoughts on what you've got out of today, that would be fantastic.
And we're going to sit here. We're not watching you because most of you have got your videos off, but yes, we'll sit here and entertain you for a moment while you fill out that feedback survey, please. And then we can take any more questions. We've still got a few more minutes, but Joe and I will be, as you know, this session is recorded, so
Dogs are getting loose.
Love it. So yes, we have recorded the session. We will be sharing the link with you as soon as we have uploaded that. And also a lot of these amazing resources and tips and tricks that have come in through the chat function today, we will also be summarising for you and any other registrations who weren't able to join us in person or online. We'll be sending that out as well. So it might not happen today, but it will happen will land in your inbox in a week or so, I'd say. Give this a bit of time. There's a lot of amazing things happening at the network level here. And so yeah, we'll get that out to you as soon as possible.
And I think too, before you all jump offline, I'd really like to thank you all for making the time to join us today, and also a special thank you to all our presenters today. We really appreciate having you join us for this, and we certainly couldn't deliver these events without you. So thank you.
Thank you. Yes. And Ray's just
You're
popped in the
welcome.
chat. I think that's worth mentioning, Ray, that you are looking for gorse infestation. So yes, if anybody knows of any gorse infestations, then Ray would love to know. So
Yes, so we want to have some samples of gorse to include in our genetic analysis, and we're trying to get samples from all across Victoria, samples representing various populations from across Victoria. So we're trying to get a wide distribution. So if you are willing to help us collect some samples, send me an email, and then I can send you out a collecting kit with instructions on how to go about collecting the samples. So it'd be fantastic.
I'll definitely do that, Ray, if that's okay. We have
Yeah.
a couple. Boxthorn as well, did you mention? Is that the same kind of setup?
Boxthorn, yes. So for Boxthorn, we're looking for sites where we're going to release the new fungus. So
Yeah, you can put it in my paddock if you want.
Yeah, great. So these are sites they're going to be set up for the project goes for 5 years. They're going to be set up for 5 years, where we will release the rust and then monitor the impact of the rust on those plants for 5 years. So these are experimental monitoring plots. So they need to be basically set aside for that period of time so that we can collect annual assessments on those plots. So if you've got a site that has a nice, at least 20 bushes that you're not planning on controlling for the next 5 years, that's the kind of site that we're looking for.
Awesome. Yeah, I reckon I can get you a couple from around here. Yep.
Thanks, Ray.
Good.
Luke, put your hand up.
Yeah, just a quick question for you, Ray. In terms of collecting samples for gorse, how far apart do you want different samples, like council by council or property by property?
No, catchment by catchment.
Okay. Yep.
Because
Thank you.
we don't want to collect too many samples that are too close together, because they may all just be the same genotype. So we're trying to cover different areas to see whether we can pick up any genetic differences. But it's quite expensive to do the DNA analysis, so we can't obviously survey every population. So we're trying to get representative populations from different catchments.
Okay.
Yep. Great.
Brilliant. And Brian will pop you in touch with Ray about some potential boxthorn sites.
Yeah.
Fantastic.
And just one final shout out that the Victorian Weeds Conference is happening this year in October at Hepburn Springs. I'm not sure if you've seen any advertising about that, but yeah, if you want, I can send through a link to it. But yeah, we'll have a biocontrol display there, and there'll be lots of great talks from people all about weeds.
Okay, brilliant. Thank you for that, Ray. Send that through and we'll send that in our follow-up email to everyone.
Great. Thank you.
All right. Well, thank you, everybody. Please do that survey, because we'll humbug you again in our follow-up email. If you haven't done it, we'll ask you again. It really does make a difference to us and allow us to report back to funders and argue the case for next year's round of webinars. So without further ado, I think we can stop recording for now.